Now we are going to run ROMS using the local location and also the forcing, climatology, and initial condition NC files. So,
Okay.
Chua, what do I do first?
You just have to go into the ROMs folder, and we will check from the files necessary in the test case. Yeah, in the case we are testing.
All right, so I logged on to the server and now I am
ROMs
going
project.
to this project folder. Oops. Okay, now.
Okay. In here we first need to uh check the upwelling header files.
Uploading data files. Which are
Header file.
oh, header files, okay.
Yeah.
Okay.
And we should edit accordingly that we need to add.
Okay, there's a few things that we've added and removed, right?
Yep.
So I think the easiest way is for me to just copy and paste.
And change the name. Yeah.
Change the name to Penang, or we can leave it as Upwelling.
We have to, like when we shift the folder to shift this file to there, then we just change the name to upwelling.h.
Shift the
Yeah.
folder to
Shift the pinning for header file
okay.
inside this directory, and then we change it to upwelling.h.
Oh, that means we are using the Upwelling header name.
Yeah, we have to use the name.
So why don't we just copy the Penang 4 header, the information in Penang 4.h, and then we just paste it inside the upwelling.h.
Oh, can also.
Yeah, same thing, doctor.
This
Yeah.
works the same.
Okay, maybe we can just describe a bit about what we activated and what we did not activate.
Yeah, for the tutorial.
Yeah.
Yeah. So here, I think this is a default solve 3D, and then we define radiation 2D, define UV, define UV core. The description is written here on the right. Define mix SUV, mix GOTS, splines, VDiff, DJ, grad, PS, TS diff, and so on. Salinity, yes. GLS mixing. This is the vertical mixing. Is that right? Chua?
Yeah. Yep.
And then since we define that, then we define the Kanta Clayson, N2, S2, HOR average, RI spline, and a vmix. Oh, you do see this text file, right?
Yeah, we do.
Yeah.
Yes, that means we're using this because we define GLS mixing, but if we did not define GLS mixing, then we will use the ANA vmix, but since we're using this, and definitely we'll go into here. And then other than that, then the vertical mixing, then we use it's the end if of that if define, and we analytically solve the SM flux, which is the surface momentum stress, and the bottom temperature flux, and the ANA bottom salinity flux analytical solutions. In the general part, we define curvature grid, although I'm not so certain whether this is important or not because we are solving this in at the equator. And masking is important to differentiate between the water, the ocean, and the land. Also together with wet dry. I think these two are about the same, right?
Yeah.
Activity and drying. And then we define the nonlinear equation of state. And these sets of sets of activation files or routines are meant for the surface forcing, where we use the forcings downloaded using the Mera script. So if define soft 3D, which we did define soft 3D up here, Then we will be using the core forcing, the bulk fluxes, CCSM fluxes. Do you know what this means, Chua?
Not sure because it's not in the documentation.
Yeah, that's why there's no definition here, but we activate it just to be safe. Because it's used in the Arctic test case, right? So that's why we're using
Yeah.
here. But let's say if the information or the header file is not available, I think they will just ignore this.
Yeah. If it's not if that does not have the function, they will ignore this stuff.
So so it doesn't matter whether we use it or not, we define it or not here. And then if define bulk fluxes, which we did because we defined solve 3D, and defined CCMS or defined CCSM fluxes, then we use the long wave out, the albedo curve, solar source, the E minus B, but we undefined diurnal short radiation flux, undefined analytical short wave radiation flux, undefined albedo cloud, undefined albedo file, and undefined long wave. If we this is so I think because we defined here use if computing outgoing long wave radiation and undefined long wave if computing net long wave radiation. This is just the outgoing. Well, this is the input minus the output, which is the net long wave, but we undefined that. And then the output stuff of the model, we like to see the averages in an NC file, the time average data. I think it's just one time stat, right? If we use this.
Time average data. Not sure.
But there is an output called underscore AVG, right?
Yeah, average file. Yeah.
Yeah, I think it's caused by us defining the averages. And then perfect restart is if it blows up in the middle of the run, then it will create a restart file, right?
Yep.
Or even if it doesn't blow up, it still create a restart file.
It doesn't blow up, it will create also. Yeah. But it will have like the period will be like before the one we finish like the model. It's like before the model we finish or the model blows up. The time before it. Yeah.
Okay, if define perfect restart, which we did, then we undefined, we don't require to output diagnostics, but you can if you want to troubleshoot, I think. But this is just the tracer and undefined diagnostic UV. This is for the momentum, U and V velocity components. Out double if you define out double so that it outputs double precision output fields. That means higher decimal number values, right? And if we define perfect restart, then we also define the RST single use if writing single precision restart fails. Oh, okay. So that means the restart field will be as precise as the non-restart fields based on this. Maybe, I don't know. But that's what we define and it works.
Yeah.
Of note is the vertical mixing, right? Because if we do not set the vertical mixing correctly, then the model would likely blow up because of increased velocity values in some parts of the ocean. I think because of the momentum not being set properly. But
Not being distributed.
yes, that's a guess for now. Okay, so that is the I think a very brief rundown of the settings and the header file, and I'm just gonna copy all of this and put it inside the uploading header file. Okay, I'm gonna do that right now.
Okay.
Okay, I need to okay, then go into ROMS project. use y, and then nano upwelling dot h. Oops, no.
Yeah.
Okay. Oh, it's being edited. Open anyway, yes.
Yeah.
Okay, so I'm going to select all of this. Okay. Oh, wait, sorry. And delete all of it. And I paste the new one. Should be okay.
Yep. Should be fine.
Save it. Yes.
Doctor, you check and see whether the symbol is right or not. The
Dash symbol.
the more than symbol or in the upwelling page, just to check the right side of the line, right hand side of the line is complete.
Yeah.
So that it copied properly.
Yeah.
Here we can guess
Thanks.
from the colors.
I see. Okay, then it should be fine.
Right. Okay, now done. Now what do we do?
So now we will basically we will have to copy the files. Let's say we set a folder named data lah in this directory. Then we
Okay.
just copy all the required files in it.
Okay. So make directory data.
Yeah. Then,
Okay, what do we need to copy into this data folder?
we need to copy the CLIM, BDRY, and the IC file from the example ROMS folder.
Okay.
Yeah.
I think I'll just leave this and open another text file,
Okay, sure.
and I'll copy the path. So here is the path. Copy the path. Okay, we should go into the ROMS folder.
Yeah. The
Palau.
icon, yeah.
Palau
Correct,
icon,
Palau icon.
because we downloaded all the files into this folder, right? Oops.
Yep.
Okay. Which one should
Copy
we
the three folder, boundary, climate, and IC file all into this data folder.
we maintain the folder structure.
Yeah, right.
Okay. And then the CLM. And then the data.
I see.
Oh, I see.
I see.
All right.
You can try to list the directory. List the directory.
List the directory. What do you mean?
Yeah, you list and you paste the directory. I mean, you list, then you space, and you list space directory. The home usually. Oh, no need. Just paste the directory like /home / yeah.
Okay.
Yeah,
Since
it's done.
now what?
Now we go to the Mera2 directory and we copy the forcings into it.
Also the forcings.
Yeah, just copy.
For the forcings. Okay. Forcings. Like that.
Yeah. Take a while. This is like a few hundred MB files there.
Okay. then we have
CLN. Yeah.
okay, now it's done.
We can go back to the directory later. Okay.
Okay. Now
Then okay. So first let's say we CD to forcings. Okay, we DC down. Okay. Can doctor copy this name of the name into a text file? Okay. Then the next go to the boundary and climate also. Copy the name as well.
Just put into the .in file.
Yeah, we have to put in.
oh, this test area, or we can remove.
Yeah, you can remove it later.
Okay. Now what?
Okay. Now we edit the input file. Before that, I think we don't edit. We try to build the model first.
Okay.
Yeah, by doing the build ROMS
Mm-hmm.
sh. Build ROMS.sh. Yeah.
We have to rebuild the model because the header file is new.
Yeah, right.
Yeah. I
It's
think
true.
the changes that we are going to make after this is only to the .in file, so we don't have to rebuild.
Yeah. Just in case it doesn't work, I just test it out.
Yeah, yeah.
All right, done.
Done. Okay, so let's see the input file.
Okay.
Okay, so first we move on. We will have to yeah, we also modified from here, right? Let me think. I think doctor, I need to upload one more file. Because
Okay.
we did modify the input file, like according to what we intended to.
Yeah,
The values especially.
yeah, we changed this.
Yeah, true. Give me a moment.
Yeah, they changed this though.
Yeah. First we change the path first. Maybe the GR, the not GRD name, the CRN name or BRY name. Yeah.
Yeah, the file.
Yeah, the
Hmm?
file path.
The file path.
BRY name.
Okay, BRY name.
Yep.
Okay, here it is.
Okay. We change the path and the directory. So in this case, right, we just change, you add the path and the directory name since it's one file.
like that, right?
Okay.
And then boundary is this name.
Yeah.
Okay, let's say if we have multiple boundary files.
Then we will put a vertical bar and then we enter another line.
Something like
You
this.
can see. Yeah,
Like that.
and then we enter another line. We have to tap to the
Yeah.
Like this.
Yeah.
yes.
Is that
And
correct?
then and then the second line they won't like the second line they won't need, I mean the last line they will need to have the symbol lah. Just
Okay, so let's say there are two files. Then let's say it's this, and let's say NC, and just leave it like that.
yeah, something like that. Yes,
Uh,
yeah, right. And then we need
Yep.
to change the NBC file to, let's see,
Oh,
NBC file.
yeah, to two. Like
Yeah,
that.
that's just an example.
Mhm.
Yeah.
Okay, next. Climatology.
Okay. Yeah, climatology, CRM file.
Okay. So it'll be this one. This climatology. Right? Next.
Okay. Next, we will edit the IC. We have to search INI
INI.
name again.
Okay, here it is.
Yep, we have to change it to IC.
This one. Paste. And then IC. And then you do the same thing if you want to add more files, right?
Yeah, but usually IC just one file only.
Yeah.
Yeah.
Initial condition is one.
Yeah. Possible, doctor, you can add line at the below with a commented line. With a commented line. INI name also. Set INI name. Yeah. Equals ROMS underscore RST dot NC. Yeah, just anything. ROMS underscore RST dot NC.
Oh, okay. If
Yeah.
you want to
For
do
the restart.
Yeah, if you want to restart the file. Okay, yeah. Like this is the input, the restart file.
do we
Yeah.
still need to use the the initial condition if we have the restart file?
We don't need. I
Alright.
mean, it's like it is start from that day.
Mm.
Yeah. So it's just to set up the initial condition.
Okay,
Then
next.
next maybe we can change the output file, maybe if one. Or you can check for find for ROMS underscore his dot nc. Yeah.
Okay.
This is for output. If you want to change the name to your own, then you just add in
Okay, which one?
history. This one, yeah.
Okay. What else?
And then RST don't need, I think. AVG also, yeah. I think that's these two only. Usually is these two output and restart file only. Yeah. Okay.
Okay.
And then now we change the FRC name just on top of it for Singh. Yeah, FRC name.
Okay.
Another one.
Oh, here it is.
Another one. Not this. This is
Oh,
how they set the file. This is the example.
oh, okay. Not this one. This one.
This one. Yes.
Okay.
So here we need to copy the Mera parsing files. Yeah. So the path and also Mera.
Like that.
Yeah.
Path this. Let's see first. I think I'll just do this one first. Copy.
Oh, actually there's one more directory, right? Is under data, then under forcings.
Oh yeah, yeah.
Yeah.
So
See. Maybe just check the others also later.
oh yeah. All right, and then the vertical line.
Uh, Not this. This is with well, after each entry except the last one. This is a single line with a okay, correct. Yeah, this line. Yeah. Then enter. Yeah. No need double equal.
Oh, okay.
Yeah, it's not required. Just make sure the spacing is start at the same spot.
How many files are there again? For forcing?
11. Continuation.
This.
Oh, doctor, I think it's wrong symbol. We need to change to the slash symbol
For which one?
for each different file. Yeah, for each different. Replace the line, the vertical symbol to the slash symbol.
Like that? Oh,
The other slash. Opposites of the slash.
this is forward slash. I think this is backslash.
Yeah, backslash.
Like that?
Correct. Yeah, right.
This is the last one.
Yeah.
So, okay. Done, and then copy this. The last one, there's no need for a backslash, right?
Yeah, no.
Yeah, I can just leave it.
Okay.
Number of
Then
forcing
we
file?
set the 11.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay.
Okay.
Then okay, good. Then we see the okay. We set the time steps first, I think.
Four?
Uh NDT fast. Yeah. Another one. Actually, it's n times, but it's search faster, NDT fast. Yeah. So we change the n times. We first change the DT. The DT is intervals. DT, we make,
Right.
yeah,
This is 5
this
minutes
is
because
5,
300 seconds divided by 60 is 5 minutes. So let's say we change it to 1 minute.
60 seconds.
Okay.
Okay. So number of times is we depends on how long we want to model. Let's say if one model,
Let's say 1
yeah,
hour, maybe 2 hours, 120.
yeah. Divide by 60 is wait, I calculate and see. 20
Yeah.
so it's 120. Yeah, right.
It's 2 hours, right?
If it's 2 hours.
Let's say
Yeah.
if 4 hours times sorry,
So
6,000
it's 3,006.
because it's 60
So,
seconds. Oh yeah, and then times 60.
Mm-hmm.
No.
no, it's
60
this
times 60 is 1 hour is 3,600.
yeah,
10 times 24 is 86,400.
yeah.
This is for 24 hours, right?
Let's see. 60 times 60 times 24. Yeah, right.
Okay, let's say 12 hours. So it should be 43.
Mm-hmm.
Of course, you're not going to wait until
Just half it lah. Mm-hmm.
Yeah, and then we need to divide by 60 because this n times is based on 60 like every 1 minute. So we need to divide by 60 again from 432. 43200. Yeah. So it's around 720.
720 outputs. Right.
Yeah, 720 time steps. Yep.
Okay, then
We change the n times to 720 and then n times ANA and FCT also.
Yeah, both 720 as well.
Yeah.
Huh?
The n times ANA.
Okay,
Yeah. And
change it to
720.
okay.
Okay. So 12 hours. Then after that we set the n his try to search for n his.
Okay, and his.
Yeah.
All right, and his.
Okay. So this is like it will record every 72 times steps, 70 seconds step. So if let's say we want 30 minutes, we have to set 30. It will calculate at the 30th step. Means like it will record at every 30 step. Yeah.
Every 30 if you want it to be 30 minutes, but that really depends on our
DT.
DT, which is
Yeah.
okay. That means if we put it at 90,
Mhm.
90 seconds, then if you still want it to be at 30 minutes output,
It will be 24, is it? Let me check. 24 times 90. Wait.
say you put it at 90.
It's 20, I think. Every 20 steps.
So we like 20 times 90.
Yeah.
100 seconds, right? Divided
Yeah.
by 60, 30 minutes.
Yep.
Okay. So I say I'm going to use 90 because if you use 60, then it's just times 1, and then we don't really see the
Yeah.
calculation.
Maybe we should change the NAVG also. The average file.
This is the delta T,
Delta T.
Mm-hmm.
and then here It should be 30 times
Delta
dt.
dt. Yeah, delta t.
let's see, dt capital.
Mm-hmm.
Same goes to the NAVG also. If we want to set.
Here. Right.
Yep.
Yeah.
Okay, then
NAVG average also.
here it is. Okay, same thing.
Yeah. 30
Yeah.
times that.
And then we scroll down again. See. Yeah. And diagnostic. I think all these can change also. The 72. Yeah.
Yeah, just standardized
It's,
basically like this.
yeah.
This one too.
It's like the other output. Yeah, just change it. Although we might not have that files, I think.
Yeah, because it's false.
Yeah. Maybe. Yeah.
Unless we mark it as true, then we will produce those files, I think.
Okay. Yeah. Then now we move on to the we go to, let's see, I can't remember
The boundary thing, is it?
we have to go to Chapman. Maybe we just search for boundary, lateral boundary condition. Yeah, it's down there.
Yeah.
Okay, here it is.
So we maybe can open the input file. I just save it at the folder in the Penang ROMs folder.
Okay. Okay.
Same, in here we search for the lateral boundary condition. Okay, then we can change the function accordingly. Chapman step skin, pet skin, close.
Mm-hmm.
It's the same.
Yep. Okay. All the same.
Yeah, all the same.
Just follow.
Oh, it's the same. And then
The last line also. Yeah.
SHC, doctor.
oh yeah.
Yeah, all SCH. I just realized.
Oh, I see.
Okay.
Okay, then we change the temperature and salinity also.
Okay, by the way, this chi thing, what's chi? Chi is Chapman
This-
Chapman explicit free surface, while SHC is Spetchkin 2D momentum
Yeah.
for the U bar, V bar, and then for the
Yeah.
UL, is radiation nudging or rad nudge. And then the MTKE, I'm not sure what that is. CLO is closed. Mixing TKE, okay. Mixing TKE is closed.
Yeah.
All right. Then the LBCT bar, all radiation nudging.
Yeah.
Is this correctly?
No.
Be like this, right?
Yeah. Yeah, like that. I just realized something, doctor. It's like the V bar and normal UV, right? Actually, the V bar is barotropic, and then for the normal V we see is like a baroclinic. So it's like 3D. Yeah.
And what does that mean?
So I'm not sure. It's like one doesn't affect by the temperature, air temperature. I think.
Which one?
Yeah, but the three-dimensional
Three-dimensional where?
three. Oh no, it's a three-dimensional UV momentum.
Okay, yeah.
It's a baroclinic. Yeah,
Mm-hmm.
then it will use the baroclinic thing. I mean,
Mhm.
yeah. Then if it's a 2D is in bar UV bar. Yeah.
Mhm.
Then it aerotropic.
Okay.
Yeah,
Well,
it's
let's
just
see what it means.
no. Oh,
What
it's
does
nothing. It's just to say it. Yes, actually, uh, it's like one is two-dimensional, then one is three-dimensional. Yeah.
the other one is U well means U velocity and V velocity, is it?
Yeah. The usual one we see
Mm-hmm.
in the output.
But the U bar and V bar is seeing the barotropic.
Yeah, it's like two-dimensional lah.
Mm-hmm.
Possible
Okay.
because they average it, maybe.
Mm.
Or don't
I
know.
see.
Okay. Next.
Next, we go on to the thing. We need to scroll down one by one to check each of it is
Check what?
the function. Is it each of it correct? I think yeah, scroll down a bit more. All this is false. Yeah, this one.
Okay.
We check and see that file, see whether it is same or different.
It's different. TNU, harmonic biharmonic horizontal diffusion of tracer for nonlinear model and adjoint base algorithm.
8 times 5.
40 TNU. Okay. So it,
Times 5. Just add it. Yeah. 8 times 5.
well, the TNU is 8
8
times
times
0.
0. TNU.
And we can remove this.
Yeah.
Okay,
1.5.
this is taken from the RT test case, right?
Yeah.
It's 8.5 and 8.8 times 0. Okay, next. Viscosity is 1.5.
Yeah.
All right. And then
Then scroll down. See. AKT but vertical mixing coefficient.
okay, we put here 8 times 1. Okay.
This is for traces. Okay, correct. And then scroll down. I think it's the same.
Now we changed these values because it could cause the model to blow up, right?
Not really. We change it because we want to like follow the Arctic test case, I think, as realistic as possible.
Oh, okay.
But if is want to configure about blow up, you have to check on the vertical mixing function, yeah, or other thing that is related. Okay, so we need to check this generic length scale. I think it's different. They use K something, K omega.
Okay, here, oh, they commented all out.
Yeah, I commented all out just to retain it, but you can delete it if you don't want to comment.
Okay.
Yeah, just change the thing.
The generic length scale turbulence closure, you put here the -1.
Yeah.
Okay, and then GLSM is 0.5. GLSN is -1. GLSK min is 7.6, and GLSP min is 1.0 d to the power of -12.
Yeah.
GMU 0.5477, GLS underscore C1 is 0.555. Oh, this is following the Arctic test case, right?
Yeah.
GLS underscore C2 is 0.833, and GLS underscore C3M -0.6,
Yeah.
1.0, 2.0, and 2.0. Okay,
Yep.
anything else?
Then we check the momentum stress. Let's see. R drag 3, 4, 2, 0 to 10. The atmospheric bulk flux, I think you have to change to 2.
Where is that?
Yeah. The original is 10 meter. 10 meter, then we change to 2 meter.
I don't see it.
Up there, bulk ZQ, just above it.
Okay.
Yeah. Air humidity. Yeah.
You put it all at 2?
Yep.
Okay. What else?
Decrease.
5.
Then the basically you can scroll down. Yeah, just scroll down and check the T nudge. Yeah, T
T9.
nudge.
Okay, it's actually 360.
Then the linear equation of state, is it? We just check and see. Is it correct?
We put here 25. T naught. Here is 14. Okay, now I change it to 35, 1.7, 7.6. 1 over PSU.
Coefficient. So 0.6. Okay. Then we change the logical switch. Yeah, you have to check the logical switch. Temperature, salinity.
Here you put as true.
True.
To read and process methodology fields.
And so it will look for the variables inside the climatology files that we created.
How come it's not looking at the sea surface height and the momentum?
It's looking
Oh, okay.
in the momentum is looking, yeah.
Mm-hmm.
Sea surface height because Arctic they didn't define. Yeah, but we can define as well. Well,
Anything else?
okay. Let's see down there. Check and see. Mm, maybe you can scroll down again. I think basically this, let's see the output. Basically output we don't need to change. Yeah, this is just to see the
Yeah.
output, whether
Inside
they create it.
inside the file, right?
It's, yeah, they mention this is history file, that means it's the output for history file. And
Mm-hmm.
this is quick save file. Yeah.
Okay.
Usually we edit the history file if we want to know
Certain
the
parameters.
output. Yeah.
Okay, so now what? Then
So
first.
yeah, just save it.
Okay,
Okay, we save it. Okay.
done. Saved already.
Then we try to run the model now.
So running the model is
Slash
ROMS G. Then the ROMS upwelling. Do we need to put anything at the back? No, right?
no.
Oh,
Okay.
Okay, something related to the naming usually.
okay.
I think you can just go up a bit.
You scroll out a bit and check the error, is it? Yeah. It could not read the input file for this, which means the path we set it wrong, basically. It cannot find the,
Oh yes, we forgot to change. Yeah.
The day, is it?
No, the folder.
Oh, okay.
the path is wrong.
Okay, so I should get BRY name first. I should put BRY.
BDRY, yeah.
Oh, yeah.
Okay.
There are folders within the data.
Yeah.
Where we put IC.
Oh
And
no,
then,
this is
No, that's
CLM.
not IC, doctor. That's CLM.
oh,
IC is INI. Yeah.
INI name.
portion's correct. Oh, where's INI?
Okay,
I think it's
just
above.
search INI, doctor. Next one. Okay. Yeah, this one as well.
Yeah.
Okay,
Save it and try to process.
it's working, right?
Yeah. Let's see first.
Still reading the files.
Mm.
Oh.
Okay, let's see what's the error. Check the error. Okay. Okay. Error requiring zeta type. Okay, I know why. Okay, this one we need to change the var info.dat.
Yeah. The one. We forgot to change that.
Yeah.
Okay,
So we search for we search for zeta time. Let's see. Okay, we change to ocean time. We change to let's see. I
This one.
think basically, yeah, the naming of the ocean time. So
Okay.
let me think. Uh, uh, let me compare with the origin for first.
Mm-hmm.
Okay, we change to zeta time for this zeta.
Mm-hmm. Here, ocean time to zeta time.
Yes, ocean time to zeta time. Let's
Mm-hmm.
see. Yeah, the doctor tried to search for the other zeta.
Um, zeta tide.
This
Yeah,
one also need to change to zeta time, right?
yeah. Basically, the ocean one need to change to zeta time. Oh no,
Zeta
this is
D.
not. This
Hmm?
is zeta tide. No, zeta tide is not. We just wait. Let me check. Not this. Not this doctor.
Okay, this one can
Y-
remain.
Yeah, we just remain ocean time. Search for other zeta.
There's a lot of zeta. So do you have zeta decided? So
Oh, okay. Let's see. We search for. Wait, we search for forcing variables.
um, forcing variable like that.
Yeah. Do you found see
Yes.
there's any see there's any zeta time? No? The other one maybe search
Like,
ocean variables.
Just now above had zeta east and all. They had
yeah,
zeta time. I
the
see.
initial one was just zeta, and then we changed the ocean time to zeta time. Is that correct?
Yeah,
That's for the
it,
initial one, but I'm not sure about the others.
that's right. We should search for like the others one maybe like other like tidal we didn't use, right? Tidal forcing variables we didn't use. We search for like the one we use
No,
forcing
river also no.
variables. Reverse no. This is
Yeah.
climatology, right? We
Uh-huh.
change. We search for atmospheric forcings. We check. Yeah.
Um, I don't quite understand. I'm a bit
Okay.
worried about the initial one, the initial zeta, because okay, this is
This
fine.
was originally ocean time, right? But we changed to zeta time.
Let me just
We can just try.
where's that? This the first zeta is this one. You see zeta free surface meter and then
Okay. We scroll down and see what is the category under this zeta.
model state variables.
Okay. Model state variables. Uh, model state variables means that it's the model.
Yeah, it definitely uses lah.
Definitely is. So the one they search is forcing. We try to search for atmospheric forcing under the zeta time under the atmospheric forcing. Yeah,
Okay.
there's a section we need to scroll through. Yes.
Tracer flux, distributed variables,
This one.
mixing variables, boundary variables, forcing variables. Okay.
Yeah,
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 it
that's
should be
perfect.
the one.
We check. Is there anything called zeta? It's a lot.
Yeah.
Nope, nothing.
Don't have. Maybe you can check the error. Where does it from? You check outside, see the error.
Maybe
Okay.
just try to run it again after to get the error. Or you want to check? Because
Let's
we
see.
changed one variable already, right?
No, we didn't change.
Oh, we didn't change it.
Not sure about that.
Okay.
Okay. You
So,
scroll through. You see. Okay. So when it after it finish the Mera range, okay, error inquiry for zeta time.
In boundary file.
It's in boundary found. It's not found. Yeah, it's in boundary found.
So we have to check
So
the boundary variables, right?
yes, we have to check the boundary files variable. Okay.
yeah.
You check for boundary variable. Boundary.
Okay.
Here.
Okay. So it's trying to check for zeta time, right? Is it?
How
Let's
does
see.
it? Yeah.
Let me see. I check and see.
I think it's supposed to change to ocean time.
Yeah, we are supposed to
Yeah,
change it in time.
true. For
Because
this,
I.
right?
Yeah, you're saying, Chua?
Oh yeah, because for boundary and climatology files, right? Basically, they save it as ocean time.
Yeah, in the files itself is defined as ocean time. So here we have to define as ocean time. So
All right.
Yeah.
Okay, so
We set it all to ocean time
yeah.
for these boundary variables. Yeah. Zeta west. Maybe need to copy it.
right. Just do it one by one.
Okay.
Not that many. It's just 4. Okay.
No, there's more. Let's see. U bar
Okay,
is U
just check.
bar B.
No,
Because
there's
just now we got about 4 errors only. Right, couldn't read.
hmm.
But
So
I think it's best to change all lah.
yeah,
We see.
we'll just go through and see if there's any more.
All
Yeah, it
the
should be reached.
I saw there is no more. See?
Yeah.
There is.
Huh?
There is salt time, and all of this need to change to ocean time, I think. But
Oh,
yeah,
Maybe is it?
maybe you can run
with
first.
every
We can try to
yeah,
run it first
can try.
just to see what it turns out.
Okay.
Same thing, is it?
We scroll, is it?
Okay, V2 time. Yeah, so we have to change all.
Yeah,
Yeah, all to ocean time.
yep.
Inside the boundary file.
Boundary variables. Yes.
Okay. Ocean time here, ocean time. Okay.
V2D.
Specify this to it one by one.
Okay, sure.
Yeah. I think this is what do you call it? Because when we download the data from the server, right?
Yeah, they save it as ocean time.
Mm,
So if you want to change, we have to change it from
on the
the
script, right?
yeah
But I don't think that's necessary, lah. Yes, it might complicate
yeah
things some more.
yeah. If you change one, then you need to find other whether there is using the same thing. Then we need to change. Yeah,
Yeah.
change the naming. You south user need and you VSP.
Okay, done.
Okay. I think for climate files might need to change as well.
Done.
Oh, it doesn't require it.
Mm-hmm. All right.
How
Probably
come it
the
doesn't
climate
require it?
files are formatted properly.
It's running
I
faster.
see.
Oh, okay.
Because the screen
Small
is small.
region. Yeah.
Blow.
Okay. Let's see what's the error.
It's here, I
Okay,
think.
the velocity is 90, is it? Let's see the velocity.
94.
Yeah. Yeah.
So it's jumped from 10, 11 to 94.
Yeah.
Okay. So we need to reduce the timestamp, I think.
Yeah, let's try it.
Max density is 5.43. Okay, let's see.
So we'll go down to 60.
Then we change the end times.
To make it
End
higher.
Oh, okay.
If you still want to remain running for 12 hours, right?
Yeah, we have to set like at least uh is 720, is it? 60 times 7. Yeah, 60 times 720 is 12 hours. So before that we set only, I think.
Ah, okay.
Alright.
It's already correct.
No, because before that we set wrongly. No, we have to set the end his also, doctor.
Okay, okay. Wait, yes.
We just set the number of history file and his. There, we changed to 30, right?
Mm-hmm.
We changed to
60 here.
Oh, okay. So we before that we calculate wrongly, I think. Yeah.
Is it?
Yeah.
Yeah. Correct. Because 30 times 60 is 11800. Yeah.
Okay. We can save it and we try to run it again.
So that's correct, right?
Yeah. This is smaller grid, I think. That's why it takes faster. Yeah. So you can see it's every 30 minutes it will write in the history file. Okay. Where does it stop again? Jumps
Become
to
one.
100. I think they write a reason for it. They say they write the max density they achieved to 1.7.
Where?
Yeah, they got mentioned the reason of blowing up
Oh,
in in this new, because this updated ROMs, right? The one we use in the server is the older version of ROMs.
Uh-huh.
Yeah.
okay.
So here they got different a bit. They got state
Reason.
the reason.
So now I think it's
Okay.
because of the density. So the
If we
response.
change the density, yeah,
1.78 times 12. Where's the density?
it should be in the equation of state, not or somewhere in the input file, maybe.
Yeah.
Let's try to keep on using the step
We
because smaller grid.
Okay, let's try to reduce the time step.
Yeah, we could do that as well.
Yeah.
Okay, this one we just okay, let's say we put it at 30 seconds. So it's at 30 seconds, then if I want to maintain 12
Hours you
hours,
need to multiply by 2.
Multiply by 2, yeah. All right, and here would be 30, right?
Yeah. So
That's right.
also multiply by 2 also.
100 is the calculation.
Yeah.
15 divided by 2.
Yeah.
No.
So if you want to,
Wait. No,
yeah, it's true.
No, just now what was this? It should be
60.
60. All right. This is 18. This is 30. So I want to change it down to 30, right?
Mm.
No, actually, oh yeah. So is it already correct? I don't know.
No. Yeah, correct. Now it's correct. Now it's correct. So we should change, we should multiply the number but times 2.
This one.
Yeah, we should get to 60 and his equals to 60. Yeah.
Okay.
And then others also can change to 60, but yeah. 60 on average. Right, mistake. Yeah, this one also 60.
That's it.
The n times, the analytical n times, I think need to change also. Yeah,
So which one?
analytical n times above it. Yeah, and the NR and forecasting cycle, right? Need to change same to n times. Yeah.
Okay.
Yes. Still increasing the velocity, I think. No, I think more stable than just now.
Yeah.
Although
1 whole cycle, and then next one it blows up.
Yeah. Just now it was 30 minutes, right?
Yeah, this one it will blow up here. Or it blew up. It blew up here.
somewhere here, yeah. Now the velocity is a bit decreasing, so I think it should be fine.
Stable. Okay.
5 by 4.
So now the problem was the density. So,
I think the density is related to velocity too,
oh, okay.
I see.
because when the density is high, the velocity would be lower. No, it'd be high too.
To actually move the
Yeah,
to
because
not.
everything here is actually related to the amount of momentum energy in the parcel of water, and the amount of energy in the parcel of water is related to how heavy it is or how dense
Mm-hmm.
it is. I believe that's the relationship between all this. So if one of it is high, then the other like velocity would also be high, to unrealistic values, like very dense at the same time very high values, which is improbable. Usually, when you're at high density, then the velocity will be lower. But
It
I think
is
they just
increasing.
it increases and then it decreases,
Mm-hmm.
and the velocity here shown is not like it changes in position, so it will show the highest point.
Yeah.
in the domain. So it will not, it'll be around the same value throughout the modeling run, but it will shift
Yeah.
locations in the domain. I think it works.
Yeah, it works.
Yeah, seems to be okay now.
How is your modeling run, your own modeling run for the month of December?
For 1 minute, right? I haven't checked just now.
Is it still running? Because the previous one blew up.
Yeah, it's still running now. It's at the 5th day now.
Okay.
All right, so maybe the sweet spot is 1 minute.
Mm-hmm.
Yeah, for that December month.
Okay, so I guess we can just let this run. It will take some time, right? Because how many? 1,000.